hydrogens there? Does everybody agree?
Yeah.
Does everyone understand what we're doing here? So you gotta go step by step by step and then figure it out. One more?
Sure.
Okay, how about the one below that? IHD? Is that here too? I don't know, I'm asking. Oh, I know it's good. What's the IHD anybody?
It's 2. IHD is 2.
Okay, number of signals?
3?
4. I mean, there's this little thing at 12
there's
volts
4.
so that you can't disregard. So A, B, and C, D.
Yeah.
Okay, integration. Let's try and measure, let's try and figure it out. It seems to me, and I'm really just eyeballing, maybe I should. Okay, so that's about 5. This is about 10. This one, 1, 2, about 25. 25. So this is about the same. 1, 2, yeah, 25. Okay. So what would, so if this is 1, that is 2, right? Ooh, 5 and 5, how does that work out? Especially since there are only 8 hydrogens in total. Once again, we might have to fudge a little and figure out, okay, what does 25 integration really mean? By the way, could you say that again? Are you saying something?
Someone was just thinking out loud.
1133.
3,
1133.
1133, so this also is then highly inaccurate. Did I just not measure it? No, it's about 6. Okay, so the integration is pretty inaccurate here. If it is 1133, as Eric is suggesting, so if this is for 1 hydrogen, that is for 1 hydrogen, this is for 3 hydrogens, and this is for 3 hydrogens, does that add up to 8? 8 hydrogens total? Okay. So I hope everybody's seeing how integration is something that we have to get creative about, because sometimes it doesn't match what we want it to be. Okay, let's go with that assumption and let's see where it takes us. Maybe it will take us somewhere, maybe it won't take us anywhere. But let's see. And remember IHDs too. So if this is for 3 hydrogens, then that's a methyl group, right?
Yep.
And then there's a different methyl group, another different methyl group, so 2 different methyl groups, and then that is probably a methine. But notice how it's broad, this one. And it's at around 12. So what is that? So what? Good. Okay, Viola, not alcohol though, let's not call it an alcohol, but what functional group is that you're thinking about?
Carboxylic acid.
Carboxylic acid. So, can we summarize what we have know so far? That okay, maybe we have a carboxylic acid, which is what signal at 12 is for. Then we have a methine. And then we have 2 different CH3s. Now what about multiplicities, guys? Let's look at the multiplicity. What's the multiplicity of this one? Right? Meaning no coupling. How about the multiplicities of the 2 methyl signals?
Singlet also.
No coupling. That means nothing is coupling with each other here. So we somehow have to again figure out how are these going to come together so there is 0 coupling going on. Ooh, that one is tricky. Okay. Suggestions? And IHD of 2. Oh, I got it. Okay. By the way, how many carbons taken care of? 4. And how many hydrogens taken care of? 8. And oxygens? 2. What's left? Is there anything left? The IHD. 2 IHDs are left, right? And carbon. Isn't that right? Yeah. And 2 IHDs. Okay. I think I got it. How do we take all of this and create a picture? So suggestions? This carbon is obviously not visible because it has no hydrogens on it. That is the reason why we're not seeing anything. So we have basically a carbon with 0 hydrogens on it.
Being the
So
center.
how do we, and oh, look at where that signal is. Who shows up here?
Double bond carbon.
Hydrogens on a double bonded carbon shows up here. Isn't that right?
Yes.
So that's indicating that maybe these are carbon-carbon double bond with, of course, other things and a hydrogen. Would that make sense?
Yeah.
Which takes care of one IHD.
Yeah.
And one IHD.
Yep.
So we've taken care of both. Are we all okay? So what's the structure?
Isopropyl and then.
No isopropyl here. Otherwise you'll have a doublet and
no.
septet.
Yeah.
What do
Methyl
you
and
mean?
methyl. Yeah. It's not actually the same. You're right. There we go.
Single.
Is that the only possibility though?
No.
Excuse me, what's the other possibility?
You can.
Should these couple with each other?
Yes. Yeah.
Careful, please
No.
slow down. Think about it before.
Oh no. Yeah.
Exactly. Should these couple?
No.
Should these couple?
No.
No. Should these couple?
No.
Is there any other possible way we could put these pieces together? Could we have also done?
No.
Why not?
Yeah.
The hydrogen can couple with the methyl.
Exactly.
Yeah, you could just
Exactly.
swap one of the
Would
methyls
these
and that
couple?
carboxylic acid.
Exactly.
Yeah.
So which one do you think is the correct structure of the two? The first one. Because here we should expect this to be a quartet and this to be a doublet, right?
Yeah.
That's all we see are singlets. So it cannot be this. Are you guys seeing that? Is everybody okay? Yes? Are you done with enough proton? Yes, I'm hearing some of you like, okay, this is
Continue.
enough proton. Is that everybody or is there someone who's thinking, no, I want to do more? Actually, can we do a more? Just one more.
Sure.
It's one of those, the second packet I gave you that has IR and NMRs together.
The more we do, the more. I don't know.
And of course, there are quite a few interesting ones, but do you see compound 4? C9H10O2?
Yeah.
It's the other side. Oh, you found it. C9, it's compound 4, C9H10O2. Everybody sees that?
Yes.
So we are combining IR with proton NMR. C9H.
Yeah.
Is this what we're learning today?
Let me
No,
undo
this is
my
another
screen
one.
to see the whole page.
This is one more.
It's this one.
Have you done the pre-lab?
Got it?
The one.
Okay, IHD. Please tell me what's the IHD.
5.
Did I hear 5?
Yeah.
And what did we say when IHD is 5? What?
Benzene.
Think about it. If IHD is 5, think about benzene. And where is the confirmation if benzene is there or not there?
Yeah.
So do we say that there is benzene?
Yeah.
Keep that in mind, that yep, there's a benzene confirmed by the proton NMR spectrum. So yep, there is a benzene. Okay, let's look at IR and tell me what kind of bonds do you see in IR. First, let's just glean all the information we can get from the IR, and then we go to the proton and then put it all together. So what do you see in IR? You definitely see a C double bond O. Of course, yes. What else do we see?
SP3.
We see sp3 what?
sp3 hybridized carbon hydrogen
So
bond.
we see sp. Please remember, IR is not an atom. IR is not a molecule or a group. IR is showing us bonds. So you you've got to be very specific that that's an sp3ch bond, this is an sp2ch bond. Probably we have carbon double
Why do we
bonds
see
here.
that?
So you see this guy.
COO. Wouldn't it be CO?
CO. It's pretty strong. A C single bond O.
1600 to
We good?
1650.
Yeah.
Everybody? Okay, so that's the main stuff we can get out of the proton NMR. Yes, Kelly?
Is the last one around
Uh-huh.
700? Is
Thank
that
you for bringing that up. Go ahead.
Wouldn't.
indicative of a benzene?
But
Yes.
what kind? It is indicative of a very
SP3.
specific kind of benzene.
Like a monosubstitute?
Monosubstituted benzene. Exactly. I was going to come from it. I was going to come back to this one after NMR, but you're absolutely right. It's actually a very strong indication to us that this may be a monosubstituted benzene. Absolutely right. Everybody okay?
Yeah.
Now let's look at proton NMR and see what are we getting off of that. So we already know IHT is 5. Okay. How many signals? How many signals? I see why you're saying 5. I heard somebody say 5, but for simplicity's sake, do you agree that's one signal, that's a triplet?
Mhm.
Do you agree that's another signal, that's a quartet? Now, for simplicity's sake, these are pretty complex because they're not clean anything. You can't look at these benzene signals and say doublet or triplet or quartet, right? They're pretty, because, so can we just call it signal C and signal D?
Mhm.
4 signals total,
Okay, sure.
and they are complex multiplicity. But the important part is, guys, please notice, both of them together are integrating for 5 hydrogens. If both benzene signals together are integrating for 5 hydrogens, what is that telling us? And confirmed there. Exactly. The fact that there are 5 hydrogens on the benzene means that there is only one other open spot somewhere on the benzene. Is that a reasonable conclusion?
Yeah.
Everyone okay?
Wait, how is there 5? Sorry, how is there 5 hydrogens?
It told you 5 hydrogens.
I know, but like, how would it be on the substituted thing?
How many total hydrogens can benzene have?
Oh, never mind. Yeah.
Benzene can only have 6.
Yeah.
So if it has only 5, meaning the 6th.
Yeah, right. Sorry.
Good, everybody? What about the triplet and the quartet? Notice the quartet is integrating for 2 hydrogens and the triplet is for 3 hydrogens. What does that tell us? There's an ethyl group somewhere also. Everybody okay?
Yes.
What did the IR tell us?
C double bond O, C double bond C.
Isn't that right?
Yeah.
How many carbons used up?
CH3, CH2, 3 carbons.
How many hydrogens
9
used
carbons.
up? Total carbon.
Okay, thanks.
How many total? 10 hydrogens? How many IHDs used up?
5.
Do you agree?
Yeah.
4 in the benzene alone and the 5th.
Yeah.
5 IHDs gone.
Mhm.
Everybody okay?
Yes.
What's left? Are there any atoms left?
No.
Is there any IHD left?
No.
Good. So that means these are the only 3 pieces we have to work around with. So can someone tell me how many possible ways of putting those 3 pieces together?
1.
I see 2. See, that has 1 open spot, but this has 2 open spots, right? So maybe benzene goes here and ethyl goes there. That's one possibility. Can't we switch? Can't ethyl go here
Oh, yes.
and benzene go there?
Yes.
How would we tell the difference? Thank you. Let's be a little bit more specific than that. What would be different between the 2 structures in NMR?
Chemical
Which one? Which one would be easiest to pick?
The methyl bond, the methylene bonded to the oxygen.
Good, where do you expect that quartet to show up?
3.7.
3.7-ish. Where do you expect the same quartet to show up in the second structure?
3.5-ish?
What?
2.2, 2.3, something like that.
2.2 to 2.5.
Where is that quartet in the given structure? It's definitely not here,
Yeah.
where it would be for the second one. It's definitely there. So we can, with a pretty good degree of confidence, say that is our compound, not this one. Everybody okay?
Yeah.
Yes, please.
Sometimes I got stuck on what you meant by 5 IHD years.
Oh, how many IHDs in the benzene? Please remember, benzene ring is a ring, that's 1 IHD, and 3 pi bonds, that's 3 more, so it has 4 IHDs. Isn't that right? And there's a 5th one right there. So what's total number of IHDs used? 4 plus 1, 5 used.
Was it talking about the 5 bonds?
Yes, every ring is a IHD, every pi bond is an IHD. An IHD basically means it's either a pi bond or a ring. So because there is a ring and pi bond, yes,
You said the ring counts as an IH.
absolutely, yes. The ring counts as 1 IHD and every pi bond counts as 1. Everybody okay? Anything else here? We good? Are we okay with proton? Will you please practice more?
Yes.
Okay, let's talk about carbon. Now, comparatively speaking, carbon, at least at our level,